All right, it's day 8, block 3, and we're going to switch gears a little bit here from those altitude median problems, and we're going to look at some more proofs. This section of proofs is particularly looking at integrating our parallel lines in a proof, so we did some work with that earlier today with the crazy angle problem, so hopefully you remember some of those postulates with our parallel lines. We'll do a couple together. You'll do some on your own here as well. But let's just jump right into the first problem. So I'm trying to prove something here. So let me draw my t-chart. Left side is statements. Right side is reasons. So I have given that AL is parallel to CE and AL is congruent to CE. So let's label our picture. So AL is parallel, so you can draw the little arrows, show parallel. And they're congruent, tick marks show congruent. And I'm trying to prove that triangle ALI is congruent to ECI. Okay, so it says to try it without vertical angles because it's definitely clearly these two guys would be congruent. So we're going to try it without vertical angles and see what we can do. So I'm noticing these parallel lines at the top here. And then it looks like I have a transversal that cuts through them. So let's see what I can say based on that information. Sometimes it helps to kind of extend the lines you're looking at like this. So you can really just focus on those angles that you want. So I see a transversal and I see these two angles here. So I'm going to give those some numbers. Let's call those 1 and 2. So angle 1 is congruent to angle 2. And looking at my picture, sometimes it also helps to kind of draw it like off to the side. That would be this angle and this angle. Okay, you see how that looks kind of more like then I can ignore this middle segment easier. Those would be alternate interior. Okay, so now I have congruent angles. I have one pair of congruent sides, so I need something else here. Well, what if I drew in this transversal? Now I have these two angles. Looks like it's the same scenario, so I'll give these some numbers, 3 and 4. Angle 3 is congruent to angle 4, again by alternate interior. So that set of parallel lines really helps us make a lot of different conclusions and see different congruencies. So I'm noticing I have angle, side, angle in both triangles, so I'm actually ready to say triangle ALI is congruent to triangle ECI. And that would be right angle, side angle. I'm done. Pretty easy. The next one is a fill in the blank. Okay, so I started it for you. Whoops, sorry. Again, the given, that's easy, so I did all that. So you have 3 blanks that I want you to try to fill in on your own. Read through the given information, read through what you want to prove, and see if you can fill in those missing pieces. All right, here's my proof. So this one's a little different than the one we just did because we were, instead of being told the lines were parallel, we were told that we had some congruent angles to start with. So I had the reason already, the definition of corresponding angles, and that would help lead you guys to see that these two lines are parallel. Another thing you can do, and I do it a lot in these kinds of proofs when there's so much going on, is I kind of just draw a little sketch of the angles I'm focused on. So I knew 1 and 2 are congruent, so I drew in the 2 lines that I'm thinking are parallel. So I just kind of sketched them over here. This is like point H and T, C and R. And then I drew in the transversal that helps make angles 1 and 2. And then I can see, oh yeah, that's corresponding angles. So these guys have to be parallel. Okay. Once I know that they're parallel, so you have to state this first, then I can say that angle 3 is congruent to angle 4. Again, based on corresponding angles, I drew the sketch down here to make it a little easier to see that. And then I have enough information to conclude that the triangles are congruent by angle side angle because we were given some congruent segments to start with. All right, so let's look at the next proof. We have two left here. I'm going to do this next one with you. It's a little bit trickier than the last few, and then you'll do the very last problem on your own. So let's draw our T-chart. Okay, so we're given that FA is perpendicular to AD. We're given ED is perpendicular to AD, AC congruent to DB, and angle F congruent to angle E. So we're actually given a ton of information here. So let's go through and label our picture based on that. FA perpendicular to AD, so that's going to make this a right angle. ED, here's ED, perpendicular to AD, so that's going to make this guy a right angle. AC is congruent to DB. Okay, so I have some overlap here. I'm going to kind of highlight these pieces in different colors. You don't have to do this, but it helps me keep track of what actually is congruent. So I'm going to go red here, kind of showing both red and blue in that middle part. So do you see the BC part is overlapping? And then I have angle F congruent to angle E. Okay, I'm trying to prove that triangle ABF is congruent to triangle DCE. And so it's tricky because right now they look congruent. It looks like we have enough stuff labeled, but not quite. So we have angle, angle, and then we have our right angle. So right now we have two angles, so we'll need a side to show that these are congruent. We don't quite have the exact side, like we don't have just CD congruent to AB. That's what we're going to need. So we're going to have to do a little bit of work with this middle segment portion. Okay. So what I want to state first is that AC is made up of AB and BC. So I'm going to write AC equals AB plus BC. Okay, and that would be segment addition. And then I'm going to do the same thing for the other triangle. So DB equals DC plus BC. I'm going to use the same order of the letters for BC to help us see some other steps. So again, segment addition. The reason this is useful is because we know that AC and DB are congruent to each other. That's something we know already. And if I can say that BC is congruent to BC, that's our reflexive property, then, so I know that these guys are congruent, these guys are congruent. That means that AB is congruent to DC, by our segment addition postulate. Okay, so now we have that those two segments are congruent. We haven't technically stated that angle A and angle D are congruent, so we should definitely just mention that. So angle A is congruent to angle D, and we're just going to say the definition of perpendicular there. So now I have that triangle ABF is congruent to triangle DCE, and that would be by angle, angle, side. Okay, so this one's a little trickier because you have to use that segment addition postulate, but it's not too bad. The last one I want you to try on your own. It's more straightforward than the one we just did. I definitely think you can handle it. As always, please label your picture. It helps so much. And then see if you can prove that the two triangles are congruent. All right, here's my proof. So just make sure you read through carefully what you're trying to prove so that you found the correct triangles, because there's a lot of triangles in this picture. So once I labeled my picture based on the given information, I knew I needed to state that the two angles created by the perpendicular segments were congruent. One thing I want to point out here, notice that I used 3 letters for these angles again. I didn't number them, I didn't use 1 letter, because those angles are easily misinterpreted. If you just wrote angle B is congruent to angle A, I'm not going to know which angle you're actually talking about. So whenever there's confusion, make sure you use 3 letters. I also can't put numbers on them because, again, I wouldn't really know if you just put a 1 here. I don't know what you mean, or that's not really what you want. That would just show this little angle, okay? So just always be safe. Use 3 letters if it's unclear. So those are congruent by perpendicular. And then you do have to say that AB is congruent to AB by the reflexive property. It seems so obvious, but you have to say it because it has to be written either in a given statement or in the proof, the 3 pieces you're using to prove the congruency. So that means we can say the triangles are congruent by side, angle, side, and we are done.